before we get into it. These are your double angle formulae that you need to know. Again, they're on the formula sheet. You don't need to learn them off by heart. They're there for you. So a double angle is essentially one that has been doubled. I don't know what other words to use to describe a double angle. It's an angle that's been doubled. So when I say an angle that's been doubled, say, for example, something like sine 70, you could write as sine of 2 times, try that again, 2 times 35 degrees. You can double the angle of 35 to get sine 70. Something like cos of, I don't know, 8a could be written as the double angle of cos of 2 times 4a. We can break any angle we want, or any angle that we're working with, into a double angle, an angle multiplied twice to get that resultant angle. And this is essentially the skill that we're going to use now when we start to have a look at this stuff. So your double angles, just quickly, sine of a double angle can be expanded to 2 sine a times cos a. Cos double angles, we actually have 3 identities. So cos of a double angle can be expanded to cos squared a minus sine squared a, 2 cos squared a minus 1, or 1 minus 2 sine squared a. So there's 3 options for your cos double angle. There's certain situations where it makes absolutely no difference which one you choose to work with, such as the examples we're going to do today, quite basic ones. There's certain examples like when you're proving an identity. So when I say prove the following identity, if you come across a cos double angle, you will need to assess what information you have. What are you trying to prove? Which identity is best suited for that situation? So there's 3 options to choose from. Like I say, you will have to decide which one best suits the situation. And we're going to deal with questions like that as of Wednesday, pretty much. So yeah, when it comes to cos, it's about what are you trying to achieve? Which one is going to help you achieve what you want to achieve? All right, so like I say, these are all on your formula sheet. You don't need to learn them off by heart. Obviously, as we start to do more and more of them, you're probably going to learn them off by heart anyways. But it is there for you. Have a look at the formula sheet I've put on Google Classroom. It's broken down into sections. You'll see them there under Trig. Right, so just to start off nice and slow, and again, I'm sorry if you feel that this is below your capabilities, but we need to be able to do the basics if we want to do the complex stuff. If we can't expand a simple double angle, if we can't take an expanded angle and reduce it to a single double angle, we're not going to be able to do the complex stuff. So we need to start with the basics and build ourselves up. We want to expand the following. And as I'm saying this, let's take this bad boy, move it so we can see what we're working with. Right, so we just want to expand the following. All we want to do is go from the double angle that we have been given in this case, either cos 2a or sine 2a, and we want to expand it to the single angle according to the identity. So what I've got here is sine of 4a. Now, remember, what this is saying to me is that I've got the double angle 4a, and so the angle that I originally doubled would have been 2 times 2a, because 2 times 2a gives me the 4a that I'm looking at. So that's where I got the double angle 4a from. And it fits into my identity that I've been given. So this is sine, sine of 2 times a being the 2a. So when we want to expand this, the expansion of a sine double angle is 2 sine of the original angle before it was doubled, so 2a, times cos of that original angle before it was doubled, 2a. All I've done is I've expanded. We were given the double angle. We wanted to go back to before it was doubled. So that's essentially why I've taken half of 4a and used that as my angle here. If I now went back to the double angle, 2 sine a cos a goes back to sine 4a, the double angle that we originally had. All right, so again, basic, nothing too stressful, but if we can't do this, we can't do the other stuff. at example B, we've got cos of angle X. Again, nothing stressful. This is the double angle that I've been given. So cos of angle X is dealing with a double angle. I want to go back to before it was doubled. Now, if you go and use the logic that I had in question A, we're looking at half of the angle that I'm dealing with, so angle X. Now remember, cos, obviously there's three different options. I'm going to write all three. You don't have to write all three, you pick one. But what we essentially need to bear in mind is that we were starting with cos of double the angle half X. Now why half X? Well, because if that's the original angle I started with, and I double that, double half X is essentially saying half X plus half X. That gives me just angle X, which was the double angle I started with. And this goes back to what I said earlier. Any angle can be a double angle. Yeah, you might have a fraction, but it's still a double angle. So based on that, we now need to use one of the three identities. I don't care which one you choose to use. So either you're going to have cos squared a half X minus sine squared a half X. Whoops. Or you will have 2 cos squared a half X minus 1. Or you will have 1 minus 2 sine squared a half X. Again, in this context, it makes absolutely no difference which one you choose to do. It's not like you're trying to prove an identity or show that something's equal to something else. You're just expanding. So in this context, any one of those three is fine. You obviously don't write all three. You pick one and you go with it. But just bear in mind, because of the context of the question, to just expand doesn't matter. If we were proving an identity or simplifying an expression, we would have to look very carefully at the other things going on in order to decide which is which. And like I said, we're going to get to questions like that. Right, if we then have a look at question C, we've got sine of angle 50. Nothing changes. This is the original double angle. So I need to ask myself, what did I double to get 50? Well, it would be sine of 2 times 25 degrees. And so when I now expand this, this would be 2 sine 25 times cos 25. So really nothing too tricky, like I said, to start off with. We need to be able to expand, same as we need to be able to write it as a single trig ratio, which we'll practice in a second. But all essentially just applying the double angle formula that we get on our formula sheet. So take a quick screenshot, and then you're going to try two by yourselves, and then we're going to move on to the next thing. Obviously, guys, if you've got questions as I go along, please ask. Again, I know that we're starting with the basics, but we need to get this stuff right in order to apply it later on. Alrighty. So what I want you guys to try is this question over here. Or these two questions over here, rather. I'm just going to make this situation over here a touch smaller so that it fits. So you are wanting to expand cos of 80 degrees and sine of 6p. So let's give those two a try. Just expand, use the identities that you've got there in the purple block. Let's see what we get. Remember, ask questions if you have any. Nice, grade 12s. I'm going to give you 1 more minute and then we'll have a look. Remember the cos or the cos double angle. I don't care which of the three you pick. In this context, it doesn't make a difference. So I will give you all three options when it comes to that, or if it comes to that. As long as you've got one of them, I'm happy. Okay, lovely children, let's have a look. All right, so the first one was the cos identity. Cos 80 as a double angle, we would have doubled the angle 40. So that's the original angle we're working with. I don't care whether you say cos squared 40 minus sine squared 40, 2 cos squared 40 minus 1, or 1 minus 2 sine squared 40. I don't care. As long as you've got one of those three answers, I'm happy. Question B, sine of 6p. So sine double angle, there's only one. The double angle is 6p, so we have to go back to the original angle that we doubled, which was 3p. And so we've got 2 sine 3p cos 3p. That's it. Okay. Nothing too tricky, but like I say, if you've got questions, ask now, because this is the time to sort out the issues. I'm waiting 10 seconds for you to take a screenshot, and then we're going to have a look at example 2, which, shock horror, rather than expanding, we're now going to write as one ratio. Okay. Alrighty, so example 2, like I say, not too surprising here. We want to write the following as a single trig ratio. Just my identities there so I can see them. I'm sure I said this to you before. I would definitely have a copy of the formula sheet somewhere, whether you've printed it out, whether it's on your phone that you can look at during lessons. Getting used to using the formula sheet now before your exams is going to be really helpful for you guys. Some of you might have already started having a formula sheet from grade 10, grade 11, so you might be used to it, but I would recommend that. Right, anyways. Write the following as a single trig ratio. Wonderful. When I'm now writing as a single trig ratio, what I need to remember is that I'm writing it as the double angle. Apparently, I can't write double angle there. So whatever angle I'm starting with in these questions, I'm going to have to double it when I get to my answer, because I'm going from the expanded single angle to the simple single double angle. What we always also want to check is that the angles do match up, because obviously you can't work with angles that are different. So you can't have, like, let's say this was 4 theta. You couldn't have sine 2 sine 4 theta times cos 3 theta. Those angles don't match up in terms of your double angle identity. The angles must be the same. Because it is 3 theta in both situations, I'm happy. I'm okay with that. And so we are using the identity that says to us that sine 2a is equal to 2 sine a times cos a. What we have been given is the right-hand side of this identity. So I've been given the expanded form. I need to go back to the double angle form. So that therefore means I need to double this angle. I'm working with sine of double the given angle, 3 theta. And so what I actually have here as a single trig ratio is sine 6 theta. Now, obviously, you don't have to write this bracket over here. It's more for us to understand that we're working towards a double angle. If we have a look at question B, we have got 1 minus 2 sine squared theta. If we look at our cos identities, that does match up with one of them. So we always want to make sure it does actually match up with the identity that we have. Can't just apply things willy-nilly, but it matches up, so we're happy. So that means that we're working with a cos double angle. And once again, I've been given the right-hand side. So I'm working back to the double angle. So I'm going to have to double the angle that I've been given here. It's a cos identity, so cos of double the given angle theta. So this is cos 2 theta. Again, nothing too tricky, nothing stressful. When we now get to question C, this is going to go back to what I said, check what you've been given. So I'm just going to move this down because this is going to be useful to me. Apparently, I'm not allowed to move that down, so we're just going to pretend everything's making sense, yeah? Okay, there are my double angles. In this question, which is now apparently 3, I don't know where we're at, but anywho. So question 3, we've got sine squared theta minus cos squared theta. So automatically we think, cool, it's the cos double angle, but it's not. If you look at your cos double angle identity, this is cos squared A minus sine squared A. I have been given sine squared A minus cos squared A. Those are not the same thing. Apparently it's an arrow now. Please remember that when you subtract terms, your order of subtraction is incredibly important. 2 minus 3 is not the same thing as 3 minus 2. It doesn't give you the same answer. So order and subtraction, incredibly important. Order when you multiply, order when you add, who cares? But subtraction, super, super important. So the problem is this current expression doesn't, cool? This current expression does not look the same as that. I need to now do some manipulation. And this is now where we need to start bringing in our algebra skills that we learned way back in our grade 9, grade 10, and we need to start bringing it into trig. I said this to you guys before, trig is algebra. Okay, obviously aside from the special things to trig, like the identities and the reduction and correlations and stuff, when it comes to solving an equation, when it comes to simplifying an expression, once you've gotten past the reduction and the correlations, it is algebra. It is manipulation of an expression or an equation. So we now need to bring that knowledge in. That knowledge says to us, the order is wrong. I need to swap the order. To swap the order, does anyone remember what we do to swap the order of terms when we have a problem with the subtraction? How am I going to swap the order here? Nice, Josh, our team, very, very nice. You take out a negative, or you take one out as a negative. No, let's try those words again. You take out a common factor of -1, you multiply by -1. As long as you are dealing with that -1 somewhere, you're good. All right, so that's exactly what we're going to do. Take out -1 as a common factor. This swaps my terms. Now we've got cos squared theta minus sine squared theta. Now this is matching up with what we want. Now we can apply the double angle. So this is going to be, now remember you've got a negative there. You can't forget about that negative. This is a cos double angle, so minus cos of 2 times my original angle theta. So we've got negative cos 2 theta. Please don't forget that negative. You've had to do that manipulation in order to get the identity to where you need it to be, or to get the expression to where you need it to be, to apply your identity. That negative is important. All right, so as you start working more with these types of, guys, I can't speak English. It's not going well for me today. Okay, as you start to deal with more and more of these expressions, you're going to see that manipulation often is a requirement, whether it's a common factor, whether it is distributing a bracket. You're going to have to do something with these expressions in order to get them to where you want to be, particularly when it comes to double angle identities. These are the ones that do require a fair amount of manipulation and a fair amount of just thinking slightly more critically about the expression that you have. All right, but let's take a screenshot of these three. I'm going to make it smaller so that we can actually take a screenshot of these three. Smaller. And then you guys are going to try two for me by yourselves. Okay, there we go. Right, so take a screenshot. And then I'm going to give you two to try by yourself, obviously based on everything we've spoken about here. And then we'll start to actually look at applying previous knowledge that we have, whether it's about algebra or whether it's about trig, to these types of questions. Okay. Cool. All right, so these are the two that you're trying here. Just take careful note of what the angle is that you've been given. Take careful note of whether or not the expression is matching up with your identity, like we saw in the previous question. I'm going to make it a bit bigger. But let's try A and B. So A is cos squared 2 theta minus sine squared 2 theta. B is 2 sine A over 2 times cos A over 2. Remember, guys, if you've got questions, just ask while you go along. Alrighty. Okay, so these two weren't too tricky. The first one, there wasn't anything wrong with the order. It was absolutely fine. Because it was the cos squared minus the sine squared cos double angle. The original angle was 2 theta, which means going back to the single double angle cos 4 theta. For the second one, not tricky, but you needed to bear in mind that because of your angle you were working with is A over 2, double that is just A. So the sine double angle there would just be sine A. Excuse me. Remember, like I said earlier, fractions are fine. There's nothing wrong with a fraction. Just remember, are you going to the double angle single term, or are you expanding out to the half angle or the original angle before it was double? And you just then need to obviously accommodate accordingly. Right, but take your screenshots here, and then we're going to have a look at the third example where, like I say, we're now going to have to start applying knowledge that we already have about trig or algebra, whatever the case is, in order to answer some questions. Okay. All right, so if we have a look at example 3, you can see now you've got some new numbers going on. So now we actually are going to work with questions where we have actual numerical values. So it says, determine the value of the following, and really importantly, without the use of a calculator. Guys, what am I implying when I tell you without the use of a calculator? What do you need to be thinking about here? Lovely, Josh. Exactly, guys. Special angles, right? So the second you see without the use of a calculator, because it mostly comes up in numerical examples, special angles. Now, from what you can see here already, there's no special angles going on. But automatically, I should be thinking, well, 15 is half of 30. So if I can apply a double angle and I can simplify this to a double angle, got 30 degrees, special angle, wonderful. All right, so if we have a look at the first one, we've got sine, we actually have 2 sine 15 times cos 15. So that's my sine double angle, which means that what I'm working with here is sine of double the original angle 15, which means I'm working with sine 30. Special angle, wonderful. I did speak about these the other day. Can't remember which lesson it was now. But you've got your special angle triangles. Again, use a calculator. If you can't remember these, just use a calculator. Okay, so that is your 60, 30, 90 triangle. You also have a triangle, which is 90, 45, 45. And that would be root 2, 2, or 1, 1 square root 2 as your hypotenuse. Doesn't matter. You also have a calculator. Right, however, sine 30, opposite over hypotenuse, or calculator, is a half. That's it. Nothing more complicated than that. If we now go to question B, again, we're not going to stress about this situation. Yes, it's not a special angle right now, but it kind of looks like a double angle identity. So hopefully, I'm going to be able to get a double angle of 30. Cos squared 15 minus sine squared 15 matches up with my cos double angle formula, or one of them. Great, no problem. So I've got cos of 2 times the original angle 15. And so I've got cos 30. Cos 30 is then root 3 over 2. So nowhere did I use a calculator. Obviously, if you don't know the ratios, like I say, use a calculator. As long as you're writing down all of your working out, how am I going to know? All right, nothing tricky, nothing overcomplicated. Let's have a look at, actually, no, sorry. Take your screenshots of these two first. Then we're going to have a look at 3 and 4, or C and D. I don't remember where I'm at. Because these next two are the ones where we throw the curveball. So these are the ones where we like to test your ability to manipulate an expression in order to get what you need. Okay, so I hope we've got screenshots. I'm about to move. So if we have a look at question C, what we have here in question C is 4 sine 105 times cos 105. So the angles are fine, they match up, but the problem is my sine identity for a double angle is 2 sine A times cos A, okay? That coefficient is 2, not 4. So once again, there's some manipulation required of me. I need to ask myself, well, if I've got 4, but I need a coefficient of 2, why don't I just take out a highest common factor of 2? So it kind of goes back to what Josh was saying earlier. Someone else said that we'll take out a negative. I think it was Ati. This idea of factorization. So if we take out a 2 as a common factor, that leaves us with 2 sine 105 times cos 105. This now matches up with my identity. So again, manipulation of your expression. You've still got this coefficient of 2 here, so we don't ignore that, so it's still there, but now we can apply our sine double identity. So this is going to be a situation of, go away, sine of 2 times my original angle, 105, and so we're dealing with 2 below, okay. I'm going to have to skip a line, sorry. 2 sine double 105 is 210. All right, now we're not done because the question, remember, originally said, determine the value of the following. I have yet to do that. So now we have to start thinking about, and this is why I said earlier, we're going to have to think about all the knowledge that we have already got from Trig. We're going to think about how I can get this to be a special angle. Now, if you want to use a co-ratio of 270 plus or minus, fine. So in this case, you would use 270 minus 60 co-ratio, that's fine. I said to you before that where possible, I will avoid co-ratios. There's a name change that needs to happen. When it comes to 270 co-ratios, there's sign changes as well. There's just too many things that we can potentially forget to do and then we go wrong. So if I can avoid a co-ratio, I'm going to do that. In this case, I can avoid a co-ratio. So in this case, I can actually say, why does it hate me? 2 sine of 180, okay, plus 30 will give me, I'm going to write here, sorry guys, I don't know what it is. Sine of 180 plus 30 will give me that 210 degrees. That's a special angle. 30 is still a special angle. And now I can go and apply my reduction. Now remember, according to your cast diagram, 180 plus is in quadrant 3. That's where tan is positive, which means the sign is actually negative. So now you've got a negative 2 sine 30, because now you've applied your reduction. And now you can use your special angles. We've already done a sine 30, so we know this would be negative 2 times a half, which will give me negative 1. There's nothing wrong with that. Obviously, if you want to use the 270, just to show you, it would be fine. You would have 2 sine of 270 minus 60. Now that's a co-ratio. 270 minus is again in quadrant 3. This is where both sine and cos are negative. So there is a negative name change to cos of 60 degrees. If you go to your triangles that we had earlier, cos of 60 is adjacent, so 1 over hypotenuse 2. So it would be negative 2 times a half, which is exactly the same as what we had in the previous method. So once again, there's absolutely nothing wrong with using the co-ratios. I just avoid it because if I forget the sign, if I get to change the name, then I'm screwing up the whole thing. So I personally would not do what I've done in orange. I would do what I did in blue, but that's just me. If you're happy with the co-ratio, go for it. All right, so that's one way that we like to throw a curveball at you where the coefficient doesn't quite match up and you need to go and manipulate, and then also having to apply a reduction. The second way that we like to throw a curveball is just your basic knowledge of algebra. So what we have here is cos 15 plus sine 15 squared. Now remember, this does not match up with your identity. That's cos squared A minus sine squared A. Okay, it's not the same thing in any shape, sense, or form. Firstly, this is a plus, so it's a sum of, and the square is on the outside of the brackets. And what we need to remember here is that when you've got a bracket squared, what you're actually doing is you're multiplying that bracket twice. So we are saying cos 15 plus sine 15 times cos 15 plus sine 15. So we've got a binomial times a binomial here. And this is now going to take us back to our basic algebra that we learned in like grade 8, grade 9, and being able to distribute a binomial times binomial. So I don't know how many of you remember foiling, but this is essentially what we're going to do. I don't know how many of you have used foiling. Essentially, all you need to remember to do is that you have to multiply the first term to both terms in the second bracket and the second term of your first bracket to both terms in your second bracket. However you choose to do it, if you FOIL, if you distribute, I don't care. Do what makes sense to you as long as you can do it. So if I go and distribute, I end up with cos squared 15 plus sine 15 cos 15, come on, plus sine 15 cos 15 plus sine squared 15. Now back to the algebra, look for your like terms. Hopefully what you can see here is the fact that, and hopefully also what you remember from algebra, is that these middle terms are often going to be like terms. More likely than not, they're going to be like terms. When you're multiplying the same bracket twice, they will definitely be like terms. So when all said and done, we can simplify to cos squared 15 plus 2 sine 15 cos 15 times plus sine squared 15. Right, so I want you guys to take a second and I want you to tell me, do you see any identities that I can apply here? So based on these three terms that I have, can I apply any identity that we know right now? You're also welcome to unmute yourself if you want, but you can just put it on the chat. What identities can I apply?
Miss, 2 sine 15 times cos 15 will equal sine 30.
Excellent. Okay, so Josh has told us that this middle term, this middle term over here is the sine double angle identity. We can simplify that. So this is going to be sine of 30 degrees. Wonderful, wonderful, because that's a special angle. But then what we have left still is the cos squared 15 plus sine squared 15. Is there another identity I can maybe apply here?
Cos squared 15 plus sine squared 15 will give you 1.
Lovely. Nice. IT and Josh, you guys are on it tonight. Amazing. Okay, not to say everyone else is not on it. They've just been answering a fair amount, which I appreciate. Exactly, guys. So remember your identity from like grade 10, the fact that sine squared theta plus cos squared theta is equal to 1. You can't forget about those identities that we learned a while back. The tan identity, as you remember, sine over cos is equal to tan. This situation that I have over here, apparently like that, is the squared identity. So actually what all of this simplifies down to is sine 30, which we already know is a half, plus 1. A half plus 1, 1.5. If you write it as an improper fraction, that's how I would do it personally. Or obviously a mixed number, or as a decimal, anything is fine. I prefer fractions, so I would leave it as an improper fraction. You do you. Right, so guys, this example is showing you firstly that you need to be able to apply your basic algebra, but also showing you that in a question, I'm not necessarily just going to test one identity. I'm going to, more likely than not, test multiple identities at the same time. Again, it comes with that manipulation. And again, just knowing your identities. Remember, I say to you as well, the squared identity, so the sine squared plus cos squared is equal to 1, and the tan identity are not on your formula sheet. You need to remember those. All the other identities, so the compound angled identities and these double angle identities are on your formula sheet. But the Pythagorean or the squared identity and the tan identity are not. So please make sure you remember them. Right, you screenshotted A and B. So let's quickly screenshot C and D before you try to by yourselves. There we go. So let's take a screenshot and then I'll put up the questions that I'd like you to give it a try of. Okay, so hopefully what you're starting to see is that everything you know from trig, you have to be able to apply. We applied reductions. We did a co-ratio if that's the way you felt. We applied identities, not just the identities that we're looking at. These are the sorts of These are the sorts of questions we need to start being comfortable with. All right, so these are the two questions. Obviously, you don't have to try both. Okay, no, that's not going to work for us. You pick which one you want to do. Obviously, if you would like to try both, absolutely. I'm not going to give you any hints because if you've been listening to the last examples that we've spoken about, you should be a-okay when it comes to this. But let's try these two. 3-4 minutes, and then I'll do the answers as we end off. Remember, guys, if you've got questions, please ask, because this is pretty much it in terms of basics. As of Monday, we are stepping it up and we're starting to really get into our trig. Okay, guys, I'm going to give you 1 more minute and then I'll put up the answers. Liking what I'm seeing so far in the chat, very nice. Okay, guys, let's have a look. All right, so the medium one, what I want you to, or what I hope you noticed, is this 1 minus 2 cos squared of an angle does not match up with the identity. The identity is 2 cos squared minus 1. So there needed to be some sort of manipulation before you could do any of that. And remember, we spoke about the fact that that would require you to take out a -1. So that's what I did first. Then I could apply my double angle identity to get to cos 45. It would be negative cos 45 because you took out the -1 common factor. And so you got negative root 2 over 2 or -1 over root 2. It depends how you learn your special angles. Obviously, if you use a calculator, your calculator always rationalizes the denominator, so it'll give you root 2 over 2. Both of them are acceptable. Both of them will get you full marks. Okay, when it came to the slightly harder one, purely because you had to do the distribution and you had to identify 2 different identities that you were working with. So it's very similar to what we just had. The fact that you had the 2 sine 15 cos 15 obviously means that you can apply your sine double angle identity, but remember it's negative. So when you did deal with the special angle sine 30, it was -1/2. And then obviously remember again the fact that you had the cos squared 15 plus sine squared 15 giving you that identity of 1. Okay, so very similar to what we did in the last question. Just because of the negative, the signs were a bit different, but very, very similar to what we did there. All right, so take your screenshots.